Hey guys, welcome. This is our first of our algebra review videos, and this is all about quadratics, mostly factoring of quadratics. And so let's go ahead and jump in. We're going to look at a couple types of factoring, and our first one is GCF. So this is our greatest common factor. So what we're doing is we're trying to look at these and we're trying to pull something out of both. So we look at our two terms in this case, and we see 4x squared and we have a 2x. So what can we pull out of both? So looking at the whole number, I see a 4 and a 2, and the biggest thing I could pull out would be a 2. And then I look at the variable and we have an x squared and an x, and the biggest thing I could pull out would be an x. So this is what I would deem as my GCF. What I want to do is then factor it out. So factoring is the process of two things multiplying. So when I'm factoring out, it's like I'm dividing. So I'm dividing these two pieces. So 4 divided by 2, that's going to leave me with 2. X squared divided by x leaves me with x minus, these are the exact same, so I'm left with 1. So this right here is what we would call fully factored. I've taken out the greatest common factor, and there's little else I can do. Now, we do have a situation where we could come up with a binomial like this that we could factor further. So here's an example, and we call this the difference of perfect squares, or DOPS. Okay, so here's an example of DOPS where you might have, I don't need that parentheses there, where you might have 16x squared minus 25. Okay, now the key word difference is meaning subtraction. So we can actually go ahead and say, here's the difference. It has to do with this piece. We are subtracting it. And then when we say perfect squares, well, 16 and x squared are perfect squares, and so is 25. So this is how we get the difference of perfect squares, and we can do a little kind of a cool maneuver. And what happens is we can actually take the square root of this 16x squared, and we can take the square root of 25. And when we do that, we get 5 and we get 4x. So what we do, the difference is that subtraction, and then we come, this one binomial makes actually two separate binomials. And the difference between the two binomials is one is positive and one is negative. Now what this does is when we FOIL, you can see 4x times 4x is going to make 16x squared, and negative 5 times a positive 5 makes a negative 25, but the middle term here would disappear. And so that's why we can kind of leave it in this form. So difference of perfect squares is kind of a special one that we need to keep our eye out for, and that's when we can go ahead and take the square root of both, they're perfect squares, and we kind of get this nice little image. Let's go ahead and look at a third and fourth type of problem. This is what we call traditional factoring. When you hear factoring, this is traditionally what we're talking about, these types of problems. So let's give you a easy term here. Let's do x squared plus 6x plus 8. Okay? So this is basic factoring. Now we've done this in class before. And so basic factoring is we want two numbers that are going to multiply to 8 and add to 6. So the two numbers that would do that would be 2 and 4. And so all we do is we take x plus 2 and x plus 4. And that's how we would factor that, and it would be pretty simple. So this is called x factoring, where we come up with the two terms. Okay? Now, we can also factor larger terms, okay? So we can also factor some larger terms. And when we do this, we could call this factor by grouping. And that is a horrible way to spell grouping, but there it is. And so we'll just take this quick example from our worksheet tomorrow, because why not? And there we go. So factor by grouping is typically when we have 4 terms and we want to go ahead and somehow factor it. So our goal here is to break these off into chunks and say, okay, let's break this up. So what is the GCF? We're going to use what we used before, greatest common factor, and it looks like I can pull out an x squared term, and I'll be left with x minus 1, which is great. Here's the problem. Over here I have negative x plus 1. See how they're not the same? What is in the parentheses of the first one has to be in the parentheses of the second one. So I can factor out a negative 1 from here. So I'm going to put negative 1. If I can get my, there we go. And if I divide that out, remember again, factoring out is like dividing the x squared out of these two. So we're dividing a negative 1 out of that, which is essentially going to change our sign. And boom, there we go. They have to, and this is one of my favorite sayings in all of math, they have to look at the same. If they don't look at the same, we're no good. So once they look at the same, we can go ahead and create that as one of our binomials. And our second binomial is what we have left over. So this and this will make up our second binomial. And we'll get x squared minus 1. And there we go. And that's all there is to it. And let's look at one last problem. Okay? And this is probably the most difficult of these kind of problems. And this is when we have a factoring when a does not equal 0. Okay? Or sorry, not 0. That would be impossible. 1. So when it does not equal 1. So let's write an example down. Okay, so here we go. We got a problem here. 2x squared plus x plus 6. Okay, so to do these problems, I want everyone to do it this way. You might learn a different way in your algebra class, but I want everyone to do this way, and that is to what's called split the middle term. Okay, to do that, we need to first multiply the front and the back number. Okay, so we're going to take this number, and we're going to multiply them. So 2 times 6 is going to give us 12. Okay? So we set up our little guy, boom, 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 and we get 12. We want to multiply to 12, and we want to add to 1, because 1 is right here in that middle. Okay, and so the only two numbers that are going to multiply to give me 12, and we want them to add to give me 1. Let me make sure I'm doing this right. One moment. Okay, I wrote down the problem wrong. I was wondering why this was not going to work. This has to be a negative 6. I apologize. So this is a negative 6. So negative 6, negative 12. There we go. Now we're on track. Now I'm like, okay, this is a doable problem now. Okay, so two numbers that multiply to give me negative 12. So one has to be negative and one has to be positive. And they make a positive 1. So that's got to be a 4 and a 3. Okay? So what we want to do is we want to split the middle term, and we want to turn it into a positive 4x minus a 3x. Bring down the negative 6 over here, and the 2x squared over here. Okay? But if you look at it, and it's true, this right here will equal that. And so that's why we call it split the middle term. Once we do that, we can factor by grouping. Okay, so we just factor this by grouping. So we look, what can we pull out? Here we get a 2 and an x. We're left with x plus 2. And now my goal is to get the same thing out of here, but see how they're both negative and I want both of them to be positive. So I'm going to have to pull out a negative. Looks like 3 might do the trick. That's going to give me x plus 2. Then we say our favorite thing in the entire world, they look at the same. They look at the same. And since they look at the same, we can go ahead and write those as one of my binomials. And then we can go ahead and write what is left, the 2x minus 3, as our second piece. So that is how we're going to be doing these in class. So this is the quadratics. We'll be doing a little bit of graphing as well. So peace out. We'll see you guys then.